here we go. Okay.
Wait, so everybody that doesn't have a calculator should have a Chromebook?
Or a smartphone out, yes.
Oh, yeah?
Yes.
Yeah?
Yes.
Yeah.
Okay.
Go get your Chromebook.
Okay. So again, folks, you know, if you're having trouble with this, okay, you need to be participating. Participating includes having a calculator in front of you, having a piece of paper, okay. Getting a copy of the notes, though, is not enough. You need to participate, okay. Getting a copy of the notes does not mean you get to check out, because that's what tends to happen. If you don't follow along with the notes, okay, you need to get a Chromebook, though, too, because you need to be able to do the calculations, okay? Do you have it, or do you have a smartphone that has a scientific calculator on it? No, so go grab your Chromebook. Okay, so go stand up, and you can go grab your Chromebook, okay? You need a calculator. All right? Yes.
So you just hit that, and then 30?
Actually, I think you're in degree, so now you should be able to do it. So the sine of whatever, cosine of whatever should work. Okay. Okay. So here we go.
I already have her number. You can call. I already have her.
I know, right? Alright. You can use that, yes. Did you put in sine of 30? You guys really listen well, right?
I just don't understand, yeah. We're in one of the most difficult parts of the unit. People are telling me constantly, Miss Wood, I don't understand this. I'm not having trouble. And then people still choose to not pay attention. It blows my mind. Blows my mind.
Hey, nobody's sleeping. Good job. Put your head up, though. His head. Oh, wait. Right sleeper.
Right. Right. Yeah, make sure you're following along, bud. All right.
You need it for a calculator.
Log into the Chromebook. Google the words scientific calculator, and it'll pop up in Google, and it'll have what you need there. Okay.
Do you need me to write scientific calculator?
Okay. So.
It autocorrects.
Just listen to it.
Does it say pairs or parts of a right? Oh, that's just parts of a right triangle.
Yes.
There's a calculator. Let's go.
Okay. So, yes, we're going to find both sides. So here's our setup. Okay, a right triangle. We want to find both missing sides of this right triangle. Okay. So, could we use Pythagorean theorem here? I mean, it's a right triangle. We could use it, but would it be helpful? No, because we only have one side.
If we had another side, we could do it.
If we had another side, we could find the third missing side. But we only have one side, so that's not helpful. Okay? Shh. Could we use special right triangles here? That is, could we use the 45-45-90 or the 30-60-90? Okay, if we could, which one of them would we use?
We use the 30-60-90.
Which one would it match to?
30-60-90.
Okay, Alex, go ahead. Which one would it match to?
It would be the second one, the 30.
Okay, why does it match to this one?
Because it's the same.
Okay, it's the same shape, but we got to look at the angles, though,
Yeah,
right?
no, I'm talking. Yeah, sorry.
Is that possible then, right? So no, it's not possible, right? Okay, Eric is what you're going to say. Yeah. So it's not possible because this is a 54-degree angle. Neither of these two special rights, Alex, neither of these two special rights here, okay, have a 54-degree angle, so we can't use those, okay? So we have to come up with another way, another method of solving special right, or not solving, but special right triangles, solving right triangles. We need to come up with something else, all right? Well, we just learned yesterday, okay, about sine, cosine, and tangent. And what's special about those is that they relate angles in a right triangle with sides, right? We could say, for example, here that the sine of angle S, in fact, let's write that out here, the sine of angle S, but I know what angle S is, so I'm going to put that in there. So the sine of 54 degrees, okay, because angle S is 54 degrees there. So the sine of that 54-degree angle is going to equal,
X over 87.
okay, remember, let's talk about what sine is here. Sine is the opposite side. What's the opposite side from the 54-degree angle? 87 over the hypotenuse. Now, we don't know the hypotenuse, so we'll call that, I don't know, we'll call it X, since we don't know it. And so we'll put it over X. Okay? We'll put it over X like that. So if you look here, what do we have? We have an equation with how many variables in it? 1. Can we solve an equation that has one variable? Yeah, okay. But what's sine of 54 equal? Well, this is why I asked you to get your calculators out, okay? I want you to type into your calculator sine of 54. Okay, and hit enter.
I got negative .55.
So you need to change from radians to degrees. So hit the mode button up there in the middle, yeah. And then arrow down and switch from radians to degrees there. Hit enter. And now go back to your again. Okay. Did everyone get something like .8090169944 like this?
Yeah.
Okay, if you didn't, we need to adjust your calculator's mode. It's important that you get the same thing as I do up here, okay? Very important, all right? Courtney, you got it on yours too? Awesome, okay? So, instead of in my equation, instead of writing sine of 54 degrees, I'm going to round it to 3 decimal places here, .809, okay? So we're going to say 0.809, I just did sine of 54, equals 87 over x. Okay? Now, at this point, now that I have a value there, what should I start doing with x here? How can I start solving? Jordan, what can we do?
Put .809 over 1 and then cross multiply.
Okay, so Jordan said put 8.809 over 1 and then cross multiply. So the 1 will multiply to the 87 to make 87, and then x times 0.809, bless you, will be 0.809x equals 87. So really all we have to do is like just multiply the x up to the top like this because the x is in the denominator, so cross multiply, yeah? All right, very good. And then last step here, what do we do?
Divide.
Divide both sides by
0.809.
0.809. That's right. Okay, and so x equals about 107. Wow. 107.54. Okay? All right. purple pen's dying, I think. All right, so there's x. And there's 87. Okay. But we're not done yet, because it says find the missing sides. We need to find both. Okay? So, how many sides of the triangle do we know now? 2. That means, what can we now use? We could use the Pythagorean theorem at this point if we wanted to. There's our a squared, that'll be c squared, and we have to solve for the b. Okay, so it'll be 87 squared plus, we'll call this maybe like y or something like that. So maybe I'll do this one in red. Okay, so if we want to solve for this side, we could use the Pythagorean theorem here if you wanted to. I am not going to use the Pythagorean theorem here. I want to use a different trig ratio. So again, you could use the Pythagorean theorem. At this point, you have 2 sides. You can find the third missing side there. I want to use another trig ratio just because that's what we're practicing here. Okay, so I don't want to use sine. I already used sine. So what other trig ratio might be a good one to use here? Alex?
Can you use
The cosine? Yep. Okay, so we could use cosine. Yep. And we could also actually use tangent here too if we wanted to. We could use tangent because tangent also has these 2 sides in it. So you could use either one. So we'll say cosine. So cosine of 54 degrees equals, okay, so cosine, the relationship is adjacent leg. So what's the adjacent leg here, Alex? What's the adjacent leg to 54? What's the leg that's next to 54? Okay, so that's adjacent to the 54, but it's not a leg, it's the hypotenuse, right? Because it's opposite, right? The y, exactly right. That's what we want. The y. The y over, and then the hypotenuse. What's the hypotenuse? What's the hypotenuse of the triangle? Yeah, 107.54. Okay. So there's the setup. Cosine is adjacent leg over hypotenuse, so it's y over 107.54. Okay? All right. On tomorrow's quiz, folks, this is as far as you'll need to go, okay? In the later tests and stuff, that's when we're going to be solving. So we're learning this today about solving and stuff, but you won't need to actually solve tomorrow. You'll just be setting it up like you see here. Okay? But on later tests and things, you will be able to. You will need to solve.
For the test, if we have to find a third side, does it matter if we use the Pythagorean theorem?
Yeah, there will be no other ones. You'll be using the Pythagorean theorem. Okay, so now we'll do a cosine of 54. So type into your calculators, cosine of 54. Okay, I like to close parentheses. I did there too. So close parentheses, cosine of 54. Hit enter, and you should get what I get here: 0.5877852523. Okay, we're going to round that again to 3 decimal places. So I'll call that 0.588 because the 7 would round that 7 up. Okay. And then that's right. Jordan said put it over 1. Okay, and cross multiply here. So 1 times y, well that's easy, what's that?
Y.
Which is y. And then 0.588 times 107.54, 63.23 we'll say. Okay. Why did I pick 2 decimal places to round to there? I don't know. You can kind of like take some freedom there with rounding, unless the directions specify otherwise. So there's your other side, 63.23. Okay. Did anyone try and find y using Pythagorean theorem? Okay. You might get a slightly different answer. It's because of rounding and stuff like that. Yours might be slightly off. So
What if it's
as long as you're close to mine, that should be good. Questions on any of that?
so this is much more precise?
Yeah, that's why I like to give them more decimal places because it's more precision. Question?
So which one put the 1 overneath it, so we just use it?
We put the 1 underneath of it so we can then do a cross multiplication.
What do we like? You don't have to, right?
Yeah, I mean, I think it's helpful to do it. Actually, I think it's helpful to do it. I know. I mean, it might seem kind of redundant, but I think it'll help you with your work. Okay, to see what to do there with the cross multiplication, just like we did for this last one. Okay. Okay. You'll notice that with these two different answers that we got, right? Finding both sides here. For this side, okay, the x was in the denominator, and so it multiplied with the 0.809, and we had an extra step to do. But here, where the y was, the y and the 1 multiplied together, and so we were done after that multiplication, so we didn't have an extra step. It was just kind of done. It just depends on how you set it up sometimes. All right, let's try another one. Okay, let's try another one here. We're going to find the missing sides of triangle DEF. Okay, and let's see here. I'll say that's D, E, and F. Okay, let's find these missing sides. Okay, I'll go ahead and put variables in here. I'll say X and Y. All right. So, let's go about trying to solve for one of these sides here. Curtis, why don't you pick a trig ratio? Which one do you want to use? Do you want to use sine, cosine, or tangent? Which one do you want to try using here? Sine, cosine, or tangent? Just pick it. Sine? Okay, sine. So we'll say sine of 76 degrees. Okay? So sine is equal to opposite, right? What's the opposite side from the 76 degrees there? Opposite side. So here's 76. What's opposite that side? So it's the y side, right? So it's y over the hypotenuse. What's the hypotenuse of this right triangle? Which side is the hypotenuse? Okay. It's the side opposite. The hypotenuse is opposite the right angle, so that's going to be x right there. Okay. Now, how many variables does this equation have? 2. Can we solve one equation that's got 2 variables in it? No. Okay? And so, we have to be careful sometimes about how we choose our trig ratios. Okay? I'm glad that Curtis did this, because while we do have choice here, we can pick sine, cosine, or tangent. I gave him all 3 choices. Sometimes the trig ratio you choose may not be helpful. If your trig ratio ends up with 2 variables in it, you don't want to use that one. Okay, so we're not going to actually use sine here. Okay, we don't actually want to use sine. But let's try cosine instead here. Okay, so cosine, Curtis, cosine is the adjacent leg. So in the picture here, Curtis, which side is the adjacent leg, or the leg that's next to the 76 degrees there? So F is an angle. Name the side. What's the side that's adjacent or next to 76? Okay, that's the 6. It's the leg. It's the leg. Okay, it's not the hypotenuse. This is the leg, and it's right next to the 76 right there. See, it's the side of the 76. So it's going to be 6 over, and then what's the hypotenuse? You remember from before? Hypotenuse. It's opposite the right angle, so it's x. X. Okay. Now, can we solve this?
Yeah, what's the 76?
Okay, Corey, you get your head up, buddy. I don't know why you're not writing anything either. Oh, you are. Okay, sorry. Okay, I didn't see. Hit it. Follow along here, guys. All right, cosine of 76. We need to find that in our calculator. So on your calculators, type in cosine 76. Okay, 0.242.
2.2.
Okay. Equals 6 over x. Put it over 1. Okay, and we'll cross multiply here. So it's 0.242x equals 6. Okay, that last 2 there looks pretty funky. Okay. All right. Curtis, what's our final step here? I have 0.242 times x equals 6. To get to x by itself, what should I do to both sides? Divide both sides by 0.242. We want to get rid of the 242 there, so we're going to cancel that out. So they cancel, and we're left with whatever 6 divided by 0.242 is. 24.79, we'll say, approximately.
You could put 24.8.
Here, 24.8 if you wanted to. Yep, that would be fine. 24.79, there it is. Okay. All right, thank you, Curtis. It's I'd rather not, but I'm hot.
I did that before, where so we could be like a teacher, right? We all got asked to do the teacher. Yeah. I remember that shit.
Okay, that should be better. All right. We have one more side to solve for here, don't we?
Yeah.
Okay. So, Addie, I know you weren't here yesterday. Okay, but we want to solve for this last side here. Okay, so at this point, we have two sides. We could use the Pythagorean theorem, right? We could say there's a squared, or this is a, so we could do this side squared plus y squared equals this side squared. We could use the Pythagorean theorem. But let's use trig ratios here, okay? So, we got the 76-degree angle here. We can pick, we already used cosine, C-O-S, so now we could use sine or tangent. All right, because now we actually know what sine is. Let's use tangent, since we haven't used tangent yet. Let's use tangent. Okay, so tangent of 76 degrees. Tangent right angle there. Okay, tangent, according to SOHCAHTOA, which is again, it's not like a mathematical thing. It's just like Roy G. Bibb. It helps remember, helps you remember your colors. This just helps us remember what the ratio for tangent is. So tangent is the opposite side. So what's the opposite side of the 76 degrees there? Sorry? Y, right? The side opposite there is y over. And then what is the adjacent leg to 76 degrees? So yeah, it's a 6, right? So 24.79, it's adjacent. It's also next to the 76 degrees there, but it's the hypotenuse. So we don't use that. We're going to use the 6. Okay. All right, Addie, so now what are we going to do?
Do the thing first.
Yeah, tangent of 76 in our calculators and get this number. Ooh, interesting. 4.011, we'll say.
4.0
equals y over 6.
Oh, you rounded?
Yeah.
Okay.
Yep. Yeah, you have to round because there's just like a million decimal places. I mean, if you don't want to round, you don't have to. You can like write the whole thing.
What did you add in?
But I rounded, yeah. Say again, Corey, sorry?
No.
You're good? Okay. So we'll put that 4.011 over 1. So it's just like in the same kind of ratio as like the y over 6 there. And then we just cross multiply, right? So 6 times 4.011 is 24.066. So y equals 24.066. Okay. So there it is. There are your two sides. Yes. Right. So there's going to be slight differences depending on rounding. Okay, mostly. Because you should be able to use, yes, the other trig ratios, and you should get, but roughly the same. But again, because we're rounding, that's going to result in different values, slightly different values. Okay. So I'll take that into account when I'm grading. You don't have to have the exact same thing as I do. But if my answer is 24.066 and your answer is 100, well, that's not rounding. That's you made a mistake somewhere or something like that. Or if I made a mistake somewhere, you know. Questions on that? Yes, sir.
I got lost because like I was following along with you.
Okay, where'd I lose you?
I got to the part where like why the
Right here?
Oh wait, never mind. I did it right.
You're good?
Yeah,
Okay,
I
cool.
thought I was doing the wrong one.
Cool. All right, so that's it. All right, any other questions? All right, are we feeling okay to just try some on our own then?
No, sure.
Yes, no, no? All right.
Yeah, no, yes, yes, yes.
All right,
Yes,
all right.
we're good.
Here we go.